All right. Thank you for the intro. So as you said, I'm Audrey Marquis, and I'm with Atonometrics. And you can see Michael Ghosteen is sitting up here. He was the lead for this project. And we also had a lot of help from Bruce King at Sandia for our testing. So again, thank you to Sandia for their help with our testing. We couldn't have done this without them. And we also had some help from the DOE for some of our funding. So thank you to them as well. So I'm going to be talking about, as we said, validation of a new product that we have for in-situ IV measurement device for PV system monitoring applications. So this will be about a IV sweep unit for a module that will be in line with your array. So in line with your inverter power producing module. But before I get into that, I wanted to go over some applications for IV sweeps. So very commonly, it's used for measuring soiling. You've heard about that some today already. We have over 1,000 systems in the field doing this sort of measurement, where you're comparing a clean and a dirty module. You've also seen that bifacial irradiance is very hard to measure. So you can use it to measure bifacial irradiance. And of course, you can track degradation and even the temperature of your modules. So here's what I was mentioning about the soiling loss. So if you had a soiled and a clean module, you would have different Pmax points between them. And if you had the curves of both of those, you could get yourself a soiling ratio and use it to track your soiling in your plant. And then we just had a talk about this. It was a great talk. Thank you for that. It is really hard to get the backside irradiance of your module. And it would be really convenient if you can measure that from a module that you already have out in the field. You can see here on the right, this is a 1 string and 2 different days of bifacial modules, and this is the irradiance on the back. So you can see that both north to south and east to west, there is not a uniform amount of irradiance hitting those cells. And of course, on the left, you can see all the sources of light that would be bouncing up on the back and on the front of your bifacial modules. There's a lot of research going on right now on using reference modules to measure bifacial irradiance. And there were a couple of talks at PVSC just earlier this year. So here's where we come in. So we are coming out with a new product, RDE300i. Like I said, this is a module level IV sweep unit. And what's special about this one is that you can use it anywhere in your array. So instead of setting up a separate reference module on separate racking or using up space in your array for a reference module that could be power producing, you can choose an array or choose a module that's already in your array and use that one as your reference module. So for a little more clarity, here's how you would hook this up. So on the top there, that would be your array, and your string current will come into RDE300i, go straight through it to that reference module in the middle, and then back out to the rest of your array and to your inverter. So here it is during normal operation. You can see that we have an IV measurement circuit in there. So you're getting your module and string current and voltage. And then if we wanted to take a full sweep, we bypass RDE300i with the string current while we disconnect your reference module to take a full sweep. So you can see the bypass diode there. So your module is very momentarily disconnected, but the rest of your array is still power producing. We have another sweep mode as well. So this is what we're calling a mini sweep. If you only wanted the Pmax, we can give you that without disconnecting your reference module. So we stay very close to the max power points voltage on your module, so we can keep it connected. And this way you would be continuously producing power with that module. So going back to the soiling, we could use 2 RDE300i's to use reference modules that are in your string. So you could choose 2 on the end here. Say, okay, well, we'll clean this one and we'll have a liter RDE300i measuring the output of that one, and a soiled one that will have a follower measuring the output of that one. And they share power and communications, and that will give you a soiling ratio from those 2 cells. And then for effective bifacial irradiance. So this was really great to use anywhere in your array because like I said, it's very complicated to measure the irradiance on the back of your panel. And you have to decide which module do you want to use and where do you want to place your sensors. And this is a great way to say, okay, well, I'd like to measure the entire back of this module here in my array. So you could choose whichever one you wanted. And then just as a note, we are rated for those bifacial modules and the new generation of higher current and higher power modules. So you can see some of our ratings there. So I've talked about some of the applications you could use RD300i for, but of course, before you go and put this in your power producing string, you want to make sure that it works and then it doesn't mess with your power production. So we worked with Bruce at Sandia to validate RD300i. And here's a picture of some of their test setup. And they provided 5 different arrays for us to test. We tested both monofacial and bifacial panels, and each of those arrays had different string level inverters from different manufacturers. And you can see that the strings we selected for testing had up to 4.8 kilowatts of output power. So here's our setup. You can see, let me see if I can figure out this laser. There you go. So this is RD300i. We didn't have the beautiful art on the front of it yet, but it's the small box here. And then this large one here is a data logger cabinet. And that's how we got our data back in Austin. So if you were setting this up in your system, you would not put it on a rack like this. But Bruce helped us set this up because we had to move it between all those 5 systems. So what data are we getting out of that? So you can see here, like one of the ways we were just reviewing our data when it was first coming in, we are continuously measuring both the voltage and current of string and module. And of course, we're taking those IV sweeps. So you can see a collection of IV sweeps here and their related power curves. And then on the top here, this is power. So we have our output power and our Pmax. Then we've got a bunch of voltages. We've got our output voltage, so the operating voltage of our module, and the open circuit voltage, and of course the voltage at the max power point. And then the same thing for the current here. So you have the operating current, the short circuit current, and the max power point current. And then not shown here, but very important, we do also have an RTD that gives us the back of the module temperature. So looking at that data in a little more detail, so this irradiance data is from Sandia. And as you'd expect, your power goes up and down with the irradiance, and so does the short circuit current. So you can use this power to get a soiling measurement, because if you have soiling, you have less power out. And you can use this short circuit current to get irradiance if you need the temperature of your module and a little bit of calibration. But if you have more sun, obviously, you'll have more short circuit current. So that's a background on RD300i. So here's what we did with all that data to check that it was working. So first for our goals, because we are in line with the inverter, we wanted to make sure that we did not affect the inverter in any way. It's really important that we don't cause any faults or any interruptions in your inverter functionality. And we also wanted to make sure there wasn't anything more subtle going on, like would we bump your inverter off of its max power point track? So we wanted to make sure that we weren't causing any faults, and then also look for any impact on energy inverter output. So there's the things we were specifically looking for. And we divided it up into a couple parts. So first we did what we're calling a functionality test. So this was mainly just to look for inverter fault events. So those really obvious, oh man, something's really wrong. And of course we wanted to make sure that RD300i was working as we expected. So to check for these inverter functions, we were looking for irregularities in the data that would indicate faults that we might have caused. So one of the ways we did that was this correlation here. On the bottom, we have the measurement of the max power point from RD300i. And this is measuring one module. And then we have the inverter power from the inverter. So if we had one module that we're measuring and then 10 in the string, if we had 300 watts we were measuring on our module, you could expect about 3,000 watts at the inverter. So if we were measuring 300 watts at our panel and for some reason the inverter was reading 0, we would have a point over here and say, hey, that's really suspicious. That looks like a fault. It shouldn't be doing that. So we investigated any points that looked like that. And then we also looked for spikes to the open circuit voltage of the string. So this was looking at the inverter data. So if the inverter stopped current at any point because it's connected to a bunch of solar panels, all of those solar panels would spike towards their open circuit voltage. So we looked for any of those spikes as well. And then one of the ways we checked that RDE300i was working was to compare, okay, so if we have this much sun and our module's at this temperature, what should the Pmax be? And then what are we measuring it at? So we wanted to make sure that we were correlating with real life. This section is a little more complicated because this is looking for those more subtle faults in any inverter power loss. So to do this, we compared two strings. So we had a string with no RDE300i, and we had a string with RDE300i, and we were comparing their energy output or the energy harvest that you could get from those strings. So this says after, because we also wanted to have a baseline comparison without RDE300i at all to account for any differences between those two strings. Because although they're the same module models, of course, they're going to have some small differences. So our baseline comparison of the energy harvest of the string that would have RDE300i to the one without, and then we added RDE300i and we compared it again. And we want this number to be very close to 1. If it was 1, that would mean there's no power loss at all. So a little note on uncertainty here. Of course, there is some uncertainty in this comparison of the strings due to irradiance fluctuations, differences in temperature, and things like that. So to manage this, we had a statistical procedure where we segmented the data into smaller sets and then compared the performance index between those data subsets. I'm not going to go into too much detail on this. I just wanted to mention what we were doing, but if you want more details, you can come and ask. And then a few notes on data collection and filtering. So we were performing both the mini sweeps that I was talking about every 10 seconds, where we don't disconnect and we measure the Pmax, and every minute we were taking that full sweep. So of course, when you're searching for faults, you don't want to filter any of your data because it doesn't really matter how sunny it is outside. You don't want any inverter faults. But when we were comparing two strings, then we did filter to exclude days with very low insolation. So then Sandia provided us a lot of data. They gave us the inverter data, and they use dedicated inverter monitoring systems. So this is not straight from the inverter. This is from a monitoring system. And they also provided us the irradiance, which you saw earlier. So we did all that testing. What are our results? So if you look here at this table, this is a summary of all of our results. So here are the 5 systems we tested, and we collected thousands of hours of data, and we checked for inverter faults, and we didn't find any inverter faults at all. So in any of these systems, we were all good on that front. Then if you look here in this last column, this is our performance index with the uncertainty, and all of these are very close to 1. That's really great. So I said earlier that if it was 1 exactly, there wouldn't be any power loss. These aren't 1 exactly, partially due to uncertainty, but partially because there is a negligible amount of power loss. And this is due to the series resistance and then the sweep duty cycle. So when we very momentarily, for like half a second, disconnect that one module, it does pull the one module from your array while the rest of it's still going. So we got negligible power loss, but most importantly, we didn't have any adverse effect on the inverter. So again, really close to 1, no faults. And I didn't include a slide on this, but yes, RDE300i was giving us real life measurements that were what we would expect. So those great results show that RDE300i is well suited for PV plant deployment. You just saw my explanations of our protocol for validating this equipment. So we had a couple ways that I was looking for fault conditions that could have been caused by our IV sweeps. And then we quantified any power losses due to any adverse effect on max power point tracking. So we didn't see any faults, and we didn't have any impact on max power point tracking or the power production of the inverter. Going back to some of the applications, it's really great that this is working, because this would be a really efficient way to use PV reference modules. You don't have to build more racking. You don't have to engineer around a reference module in the middle of your array. You can use your power producing modules for your measurements. So that's all I have for now. And thank you very much for listening.